So let's start this afternoon session. That's the last part of the session dedicated to the event, earthquake, tsunami, and all the rest in Japan, 11th of March. I thank you very much for your participation here. This event is convened by me, by Bruce here, and by Ewan Nisbet, that I thank very much for his very active role in suggesting how to conduct this panel. And we have a panelist here. The board is not complete because Professor Kato, who was one of the speakers this morning, will join us in 5 minutes or so. The structure of this panel is quite simple. We wanted at the beginning, then we changed my mind, but I want to tell you how we thought it could have been, to have a series of questions already written and collected before the beginning of this panel here, but there was some logistic problems, and so practically it's quite more simple to have the questions asked here. But let me tell you that we will anyhow be happy if there is some scheme and some structure in this panel. Of course, the topics are quite simple to identify. We should talk about the earthquake, we should talk about the tsunami, we should talk about the financial and economic impact of the event. We should talk about what was unexpected at the beginning but remained in the press for so long, and not only in the press, it was concern of everybody, so the incident of the nuclear power plants, the radiation, etc. So we try to collect here experts in this board of all these aspects, and you are free to have questions, but I would suggest you to follow this order. So at the beginning, we will collect questions on the earthquake, then we open the following phase of tsunamis, and then the following phase of the impact economic. Professor Kato is here, so, and the last topic we will touch is the dispersal of the radionuclides, etc. Of course, all these topics are interconnected, and so it's not so strict disorder, but we try to have this kind of order in our discussion. We will ask you to make questions, quite short questions, in order to give the possibility to anybody to ask, and you are also allowed in this scheme to have a comment on the answers you receive by the panelists. Even this comment, please, if you like to have it, try to have it short, not more than 1 minute. You will receive a microphone from the guys here, and they are around, and they just raise your hand, and they will give you the microphone, but they, in a sense, let me consider our role as the chair here as a role that can influence the order of this discussion. They will ask us some sign before giving you the microphone. That's it, but of course everybody can take part. I will ask now the panelists to have a very short introduction, so you should know who is the expert of what matter and or what topic, and probably you should directly address the question that you have to the right panelist. If you don't remember, we will do that as a chair. So first of all, I will just remind you their names. The names are in that screen, and so from my right and going to the left, Professor Kato, Professor Yamamoto, Professor Okal, Dr. Gero Mikkel, Dr. Stroll, and Dr. Votawa. And just to tell you the expertise in one keyword, and then I will give them the floor in order to present themselves. Professor Kato, let me say earthquake. Professor Yamamoto, let me say tsunami in Japan. Professor Okal, let me say tsunami and earthquake, so both. Dr. Mikkel, he gave a speech very interesting this morning concerning the financial and economic impact and the reinsurances, etc. And then just to cover the topic that was not covered too much this morning, indeed, and so it's important also to raise that in this panel. Dr. Andreas Stoll and Watawa, they are very much expert in dispersal of aerosol, in this case radionuclide, etc. So they can tell us something if you ask the right questions on its incidence in the Fukushima power plant. So I invite Professor Kato to give a very short introduction of himself. Thank you very much.
I'm very sorry I'm late a little bit, but I suppose many of you have already attended the morning session, so that you may already know what I told you. But just to introduce myself, again, I'm a professor at the Earthquake Research Institute of the University of Tokyo, and I'm a geodesist, and my expertise is cluster deformation using GPS. But for tomorrow morning, not just for my own field, I also extended my talk for tsunami, because that is so devastating, and none of us Japanese have made talk on that, so I represented that. But anyway, Japan is now suffering from many effects from that earthquake, including, as you know, the atomic power plant problem. But because I'm a scientist, I cannot touch on that. But even so, we have many problems which we should think more in the coming days. For example, we are still suffering from aftershocks. As you know, we had a large aftershock yesterday night. But what's going on in those aftershock activity? Is that just following a rule called Omori law, or should we expect more bigger aftershock activities? That is one thing. Another thing is that this earthquake is triggering another big one that could happen in some other parts of the Japan or surrounding areas. Also, a little more special problem is existing in the northern part of Japan, because as Dr. Sato already introduced this morning, that part is subsiding in the recent years, but in the long-term sense, it's uplifting. How can we reconcile this kind of gap? One answer could be the super large earthquake may have solved this problem, but this was not the case. So we have to think what is the good solution for that kind of geological and geodetic problem. Well, so still there are so many problems are remaining, but I'm very glad to accept your questions, which I may not be able to answer. Thank you.
Thank you very much.
Now I'm working at the IOC, UNESCO. IOC means the Intergovernmental Oceanographic Commission of the UNESCO. And at the time of the 2004 Indian tsunami, I was the director of the Japanese Tsunami Warning Center of the Japan Meteorological Agency. And after the 2004 Indian Ocean tsunami, IOC UNESCO is designated as a leading UN agency to coordinate for the establishment of early tsunami warning and mitigation system. Therefore, I was transferred from the JMA to UNESCO. And the fundamental agreement is the tsunami warning should be issued from each member state. And so in order to do so, national tsunami warning system is required. And also the national tsunami warning system should be integrated into the regional system. Regional system should be integrated to the ocean-wide systems. And also not only to issue the tsunami warning as early as possible, but also another important issue is how quickly disseminate warning to the public, and how quickly evacuate people who are living in the tsunami threat area. This we are called this system the so-called end-to-end system. In order to establish end-to-end system, we are working together with the member states of the IOC.
Thank you very much. Emilio Cal.
My name is Emilio Cal. I'm a professor of Earth and Planetary Sciences at Northwestern University in Evanston, which is a suburb of Chicago in the US. I'm a seismologist by training, but I've been involved in studying tsunamis for the past 30 years or so. I keep a deep interest in global seismology, especially large earthquakes, especially historical earthquakes, and I've been studying many aspects of generation, propagation, and of tsunamis, and I've worked in fields as varied as theoretical aspects of their propagation, and also I've done a lot of field work in post-tsunami surveys. I'll be glad to take any of your questions regarding tsunamis, and I will do my best to try to answer them. Thank you.
Thank you. Michael?
Gero Michel, I'm trying to bridge the gap between science and the insurance and reinsurance world. I'm here for a network which is the largest public-private network in our market, which relates insurance to science. I'm also responsible for the research and development of a company called Willis, who is an intermediary between retail, insurance and reinsurance, the third largest company of that size, of that market in the world. Background, I have a bit of a diverse background. I come from science, was also a lecturer in university, more on the earth science side. We did a lot in Southeast Asia and Central Asia, GPS, a lot of that. And from there went into the industry, went to a company called Hanover Re, and worked with those guys for a while in Bermuda. Went then to a company called Risk Management Solutions, where I was responsible for the wind and flood development, to the model building for that. Then after Katrina, got another call and went back to Bermuda and was there for a company called Endurance, responsible for the international cat underwriting. So where we actually made for that company a lot of money during that time with natural international catastrophes. And then since 8 months, I'm with Willis, and now trying to become essentially as I said, the link between science and our market.
Andreas Stroll.
I'm Andreas Stroll from the Norwegian Institute for Air Research, or NILU. I'll make it short. I'm an expert on atmospheric transport processes and interested in basically everything that is being transported in the atmosphere. So last year I've been participating in a similar panel on volcanic ash. This year it's on the dispersion of radioactivity. And I've developed an atmospheric dispersion model that is used by quite many people now worldwide. And you can ask any questions related to atmospheric transport and dispersal also of the radionuclide from Fukushima.
Gerard Wotawa.
Yeah, good afternoon, ladies and gentlemen. I'm working at the Meteorological and Geophysical Service of Austria here in Vienna. And I'm responsible for the simulation of the radioactivity here from the Fukushima nuclear power plant, and we do this actually since about 2 hours before the first of the explosions occurred on Saturday, the 12th of March. So very rapidly in the course of the event. Based on our background, I mean, we're also working on from the Austrian side on the nuclear testbed treaty verification, and receive the data from the system, the global monitoring system of the CTBTO, the Comprehensive Nuclear Testbed Treaty Organization, and that also allowed us early on to assess with independent data releases of radionuclides and release rates and impacts, long-range transport of this event, and therefore also gave us the possibility to compare model with reality and to look at the model performance. So questions related to the release and the long-term trend, long range and long-term transport, you can ask to me. I'm also familiar with international processes in this area. I mean, I've worked for 9 years at the CTBTO itself, and I'm currently also taking part in the meetings of the Nuclear Emergency Response Activities Coordination Group of the World Meteorological Organization. So the work of regional specialized meteorological centers and of weather centers that predict plumes from accidents and how they interact with the International Atomic Energy Agency. I'm also happy to answer on that one. Thank you.
Thank you very much. So before starting this time for questions, I inform you that all this event is webcast, not only the panelists, but everybody of you asking questions and following later possible comments, everybody will be webcast. So now we open the floor for questions concerning the earthquake first, and then tsunami. And the main idea, we saw that this very big event probably changed our view on the tectonic, the knowledge we have of the tectonic here in Japan. I don't know, probably in other regions of the world, maybe even in Europe. So it's very interesting for us as a scientist to know what really has changed, if something changed, and how we are forced to change our view. So please, McCloskey first. Wait for the microphone, of course.
Hi. I spent some time at posters this morning looking at the various slip inversions that we see for this earthquake. It seems in many of the inversions that it has been a very compact source with very high slip. This would suggest significant stress redistribution to the north and to the south, not only towards the Sagami Trough, but also on the megathrust on the Japan trench, which hasn't slipped during this event. I'm interested, given the massive amount of data that Japan has and will gather over the next while, what do you think, Professor Kato and Okal, what do you think are the main research directions that we can take now to investigate the threat of other large megathrust earthquakes which are still possible in that area?
Excuse me, before answering him, everybody should, that was my fault not to tell, everybody should identify himself, telling also the affiliation or where he's coming from. Thank you. Can you do that?
Yeah, my name is John McCluskey. I'm a professor of earthquake science in the University of Ulster in Northern Ireland.
Okay, I think I understand. Your question is what should we do in the coming days for investigating that kind of a very big earthquake? The one thing I should emphasize is that, in particular in the Japanese islands, that kind of large earthquake occurs not inland, but occurs offshore. That's the reason why we have such a big tsunami. Now, for studying earthquake of that kind, we need to have a much denser array in the hypocentral region, which is under the ocean. So it's very difficult to observe something. And so far, the Japanese government invested a lot of money to have a very dense array. As you already know, there are very dense GPS network and the seismic network on land. And we are, because of course we know that we should do more in the ocean floor, and we began to deploy some instruments like ocean bottom pressure sensors and the ocean bottom seismometers. But in addition to that, we began to deploy so-called GPS acoustic system to observe the crust deformation in the ocean bottom. But unfortunately, it was too early, and the earthquake occurred before we established a dense array of those ocean bottom observations. I do believe that in the coming days, we should deploy a dense array in the offshore, in the hypocentral region from northern part of Japan to the real southern end of Japanese island, but not just for Japan, but any subduction zones that could be eligible for the super megathrust earthquakes. We should do more investigation in the offshore under the ocean bottom observations. Am I answering your question?
Perfectly. A very brief response. I think that the deployment of ocean bottom GPS instruments is the absolute priority for understanding the operation of megathrusts.
Thank you very much. Other questions? Please.
Thank you. My name is Shuai. I'm from China. We know that 2 years ago, our country had a devastating earthquake in Sichuan province, and I think more than 100,000 people lost their lives. And also, my hometown is in northwestern part of China, so there were lots of earthquakes during my childhood. I remember quite oftenly the earthquake activities. So I'd like to ask a general question: is like, what is the difference or related to the damage between the earthquake in the land and the earthquake in the ocean? Thank you.
Okay. What I myself have done a little bit cooperative research in China, so I know something about the earthquake in China. The earthquake in China is a so-called continental earthquake, and what we have in Japan is the earthquakes along the islands. There are some differences, I think, but basically we could think that there are two types of earthquakes. One is that the earthquake that is occurring along the plate boundary, and like we had in March 11, that occurs in the ocean bottom and create a bigger tsunami. But I think the strong motion or earthquake ground vibration might be a little bit smaller compared with the earthquake that occurred right beneath yourself. So another type of earthquake is the earthquake that occurs inland, as you had in Wenchang in China. We also have the similar type of earthquake in Kobe in 1995. That one was magnitude was only 7.2 or 6.9, 6.8 or 9, but still more than 6,000 people died, and you lost more than 100,000 people. If the earthquake occurs very close to the big city or right beneath the populated area, so the damage of earthquake is very large. I think that's a difference. Am I answering your question? But I'm.
Thank you. Another question from this side.
My name is Ole Hanekop. I work for Hannover Re, one of the largest reinsurance groups in the world. And I've got a question regarding the probability of earthquakes occurring on faults on land in near-term future related to the occurrence of the large event that we just had and the stresses that might have been transferred to those faults.
Okay, if I understand your question well, you are asking about the probability of an earthquake occurring in the wake of that disastrous event, no?
No, it's more related to, I mean, if I recall correctly, some of the aftershocks were not actually aftershocks, but activations of faults on land. And the question is, what is the probability for example, having such earthquakes of magnitude 6 or larger as part of the aftershock sequence, if you would like to call it that way?
Well, clearly, the occurrence of a very major event, such as the event of March 11, changes the stress regime in the vicinity of the earthquake. And by vicinity, we may be thinking about something on the order of a few hundred to perhaps 1,000 kilometers or so. That may, in some, as was mentioned this morning, and perhaps only the future will tell, but that may, in some cases, result in a decrease of the loading when the geometry is favorable. In other cases, that may lead to an increase in the loading and to a certain extent on the critical strike on the back of a camel. if I may say. And now, whether this affects only the fault system that slipped during the main event, or can it be transported to other fault systems, is also a very open question. But there was a very clear example, which was, I think, 10 or 12 hours after the Japanese earthquake. There was a major event in Nagano, which is in the Japanese Alps, something like 300 kilometers maybe to the west, which clearly was not related to the same fault system, but one would surmise that probably there could have been an increase in stress in that region due to a major earthquake. What I would like to emphasize is that this kind of stress transfer, which is reasonably well understood and which can be modeled, and our friend John McCloskey, for example, has been very successful in the past in this business following the Sumatra earthquake. This kind of stress transfer decreases, of course, with distance. And so you have to keep a cool head not to propagate these kinds of effects a little bit too far and claim that they could have an effect at the other end of the world. There are other sources of stresses, such as tidal stresses, such as stresses which come from precipitation and so on, which may or may not be involved in the triggering of earthquake. This is an open debate, but if you go too far from the epicenter of the main event, as you described it, then the stress which can be transferred becomes smaller than these other effects, and therefore has no probabilistic influence. Am I answering your question?
Yeah, it's as well the question how much information is actually contained in maps, for example, like Gero Michel showed in his talk this morning, where stress changes were actually mapped. And I mean, obviously we don't know a lot about the stress regime prior to the occurrence of the earthquake, so it's as well the question whether that can help us to identify such problems.
Yeah, and we've shown very recent results right after the earthquake from Ross Stein and his colleagues looking into that. And one of their results is that the stresses along the Sagami Fault in 1923 might be actually reduced, whereas in other areas they increased. But I think you're absolutely right. There's a lot of uncertainty in that as well. And there's a project we're currently discussing whether it would make sense to test that worldwide, quasi-online for all earthquakes that happen, and find a way like that. I mean, I think my understanding is that this redistribution of stresses and strains, Coulomb failure and an end, that works in certain areas apparently very well. And then there are other earthquakes where it doesn't necessarily work that well. And I think there are a lot of open questions. And when it comes to the size of this earthquake, I think there are a lot of surprises, which we actually might not much, not anticipate.
Okay, thank you very much. Let's go to other question. There was one here. And then
Ewan Nesbitt from Royal Holloway. This is a question to the Japanese experts here. From this distance, it's very hard to tell just how much human impact there was from the earthquake as opposed to the tsunami. The tragedy of the tsunami is overwhelmed what looks to me like quite a success in basically minimizing the casualties from the earthquake. Could you comment on that? Anybody?
Yeah, that's a good question. So far, it's still only less than 1 month since that big earthquake. And most of media took up the disaster due to tsunami. So we do not have much information about how was the damage by the earthquake itself. It seems to me that, for example, the Sendai city, which is nearby the Haimpo Central region, I didn't see any collapse of building there. So I think not the tsunami, but the casualties of people, not tsunami, but the earthquake may be very small. So maybe, but still, maybe I'm very too early to say this because none of scientific investigation was made so far. So from now on, probably, I think since April 1st, the researcher began to send the survey team, not just for tsunami, but also for earthquake damage. So in a short time, I think we can find it out if the earthquake resilience would be, resilience for earthquake itself. Yeah.
Masahiro, do you like to add something to? No, okay. Okay, thank you. Questions?
I'm Mikhail Lavrentiev from Novosibirsk State University, Russia. I would be very much obliged for the short comments from Professor Kato and Professor Okal. Is that Tokyo should consider safe after the loading of the Sagami fault? And the same question to Professor Stoll and Votava. What about Fukushima nuclear power station and Tokyo region? Thank you.
Yeah, if I permit, this topic will be touched at the end. So please go. Let's follow the structure that we suggested. So first the earthquake. So please.
I'm not sure I understood your question.
So it is known that in the Tokyo area, approximately once in 80 years is the very strong earthquake, and the last was in 1923. And so now, should this strong event at Sendai should be considered as similar as that deload the Sagami fault?
Maybe also Professor Kato can answer.
I think someone may have showed you the result of stress or strain change due to the Sendai earthquake onto the Sagami Trough. And the results suggest that the stress dropped a little bit so that Sagami Trough goes a little bit safer side, I believe. But again, he already pointed out that there are a lot of uncertainty, and also there are other factors to trigger earthquakes, so we cannot tell that the Sagami Trough is now safe. So maybe you could comment on that.
Yes, I would agree, but I would like to take also this opportunity maybe to make one comment here, which is that the question of repeating earthquakes is an extremely delicate one. We know from historical records, we know dates, and we know approximate sizes about earthquakes, and we are drawn to thinking that they are repeat of each other's, but they work like clockwork, you know, and to maybe use the word periodicity. And there have been studies in many parts of the world, including in Japan by Professor Ando, going back 35 years, which have shown that there is an element in the sense of being capricious, and that earthquakes, large earthquakes which repeat themselves, well, they are not carbon copy. Some of them are bigger, some of them are smaller. Some of them involve a shorter fault length, some of them involve a longer short length. And so I think one of the conclusions of Dr. Ando's study in 1975, which has been upheld in many other areas of the world, is that as difficult as it is to have some idea when the next one will come, it is even more difficult to know if it's going to be 8, 8.5, or 9, or 7.5. And this is something that we have to keep in mind in the wake of such disasters as this one, and the Chilean disaster of 2010 and of 1960. Thank you.
Massimo Cocco from INGV Rome. I would like to know your opinion on the possibility to address future research toward the probabilistic inundation maps, which can be a solution to what Professor Okal was just now discussing, which is just complementary on what we are trying to do for earthquake science. So to try to develop a probabilistic approach for ground motion shaking and retard times for big ground acceleration. So we need to address research toward having the same for inundation maps, and I would like to know your opinion on this.
Well, actually, this is an effort which is being done in many areas of the world. And for example, the western coastline of the United States, in California, Oregon, Washington, You know, there are inundation maps which are based, some of them on probabilistic hazard assessment concepts which are being drawn, but this is an extremely tedious and difficult difficult process which has to be done harbor by harbor and community by community.
Comment? Yeah, please.
And in case of in Japan, the system, the national government provided some instruction how to create the inundation map to the local government. Local government has a responsibility to develop the inundation map. And also this is one of the big target for this after the post-tsunami site survey. Maybe we have to compare the existing inundation map and the actual inundation areas. So I think within a month or so, maybe we can get some answers.
Thank you. Comment if you like. So.
Just a short comment. Yeah, no, I fully agree, but I also believe that the only way in which you can handle the uncertainties, even with the magnitude, is to take into account, especially where you have a nuclear power plant, the worst case scenario. So the problem is to take into consideration even a probability of 10-7 that a magnitude 9 can strike Fukushima. And this is an approach that is a little bit more than this approach which is going on. And also, even if I understand that there are the problem of the inundation, it could be also the probabilistic measure that the maximum height of the tsunami wave that can arrive, that would be a little bit less local, and then now can be computed with the computational resource in advance. And this could be even used in a probabilistic sense, even at a larger scale.
Thank you. So we moved a bit on the tsunami, but I pick up two more questions on earthquake, and then we go on the tsunami. So 1 and 2, it's on tsunami or? Okay, 1 and 2, then we move to the tsunami, sorry. Please, yeah. Wait for the microphone, please.
Two questions, one more social science. So
no, please sure. Identify yourself.
Oh yeah, my name is Birger Lühr, I'm from GFZ Potsdam. I have read an investigation that where the people were asked in 2006 in Japan that in case of a tsunami, do you want to be evacuated? And from this investigation...
sorry, it's on the earthquake now, so please. If it's on the tsunami...
I want to say something about the tsunami. Or
no, just maybe you are the first on the tsunami later. So on the earthquake, so go here first on the earthquake and then there. Later. This first.
Thank you. Ahmet Yalçıner from Ankara Middle East Technical University. My question is there any similarities between Sumatra event and after tsunami, after earthquakes happened after Sumatra event? Can we expect some tsunamis along this trench, north part or south part, going to Philippines? Like after Sumatra event, we had several 8 magnitude earthquakes. Can we expect that kind of earthquakes from now on along this trench?
Okay. Thank you, Ahmed. This goes back to this question of stress transfer. Before even touching the question of stress transfer, I would like to answer your question in an absolute way. Can you expect earthquakes along an active subduction zone? And the answer is yes. Now, I detect in your question, can you expect, perhaps can we expect more of a probability of these earthquakes taking place? And this becomes a very tricky problem because, as we've already discussed, the question of the stress transfer is a very difficult one. In addition, what you are envisioning here, going towards the Philippine plate, if I understand, is to jump a plate boundary. And the question of how stress transfer can act when you jump a plate boundary is, I guess, an even more difficult one. And I don't think that I personally don't have any answer to this. There may be people in the room who have better answers, but my perception would be that in the case of Sumatra, the progression of the activity along the Sumatra coast from 2004, 2005, 2007 was reasonably simple, because you dealt essentially with a continuous plate boundary. If you go towards the Nankai Trough and then the Ryukyu arc and the Philippines, you are progressing against one of the most complex, a very complex tectonic boundary, where, as was mentioned this morning, you essentially have two subduction plates which meet somewhere in the mantle. And so this may be very difficult, and I don't think there would be any simple models to explain it.
Comment?
I might quickly
Thank
add,
you.
The simple answer we give normally to our clients for that, we say there's a frequency distribution and there's a severity distribution. For the frequency distribution, definitively we know, because of aftershocks, it's going up clearly, and we've seen that. For the severity distribution, we don't know.
Thank you. The last question here.
My name is Jiří Zahradník, Charles University in Prague, Czech Republic. My question is about proportion between quick stress release and long-term release in creep or silent earthquakes, because we know that the region is partially locked, but probably the locking proportion is not the same as, for example, in Chile. So I would like to know, in general, about proportion between stress release through slow processes like creep, for example, and earthquakes in this particular region.
Yeah, that's a very good question. What is most important to estimate the seismic risk along those plate boundary is to know where is hardly locked and where is well locked. So far, we have investigated a lot of things. For example, using GPS to invert for the rate of plate locking. And also, we have estimated, some people found that there is a lot of aseismic slip is occurring there. So we have so far estimated where is locked or where is sleeping pretty well, we believed. But by this earthquake, we realized that our estimation was wrong. So we have to reconsider what to do. Was our estimate good or bad? If it's bad, what was bad? So still we do not have any good answer for that kind of thing. So that's why I said for the first question that we should have more ocean bottom observations. If we know much more detail about the how the fault is locked and how big strain is accumulated, then we could tell something about that. So we are still too early to answer, but still we just go ahead and do more extensive surveys so that we could have a little better answer to you. I'm sorry, that's all what we could say, if someone could comment.
No comment? Okay, thank you. So let's go to Tsunami. You are the first. Sorry for interruption.
My name is Birger Lühr. I'm from GFZ Potsdam. So my first question, I have two questions. They are a little bit related. So I read in investigations that people were asked if in case of a tsunami, do you want to be evacuated or not? And 8% says, yes, we want to be evacuated immediately, but more than 40% say they do not want to be evacuated. Has this something to do with this huge amount of victims? The other question is, my impression is from the TV films that, and from my knowledge, that on one hand, related to earthquakes, Japan is very good prepared, but this, as I could see, this lighthouse resistant to earthquakes are not resistant to this tsunami. So perhaps we have to think about other constructions which can resist tsunamis and earthquakes. Do you think about in this direction?
Thank you. Masahiro.
As we heard, collect the information from Japan. So regarding the casualty and missing people, it needs a very careful investigation because that area is a very, very isolated area. As far as I saw the local newspapers, most of the killed people, missing people, is extremely high age. So I'm not sure they have very young people or not. So in that case, it's very difficult to evacuate. And if in order to evacuate, they need a lot of support from young people. So we have to investigate more carefully. It's a little bit premature to conclude this issue. And regarding the building or some facility, I think some building or seawall completely collapsed, destroyed. But some seawall still fine and prevent or mitigate the disaster. So it's also need a lot of surveys.
Thank you. Have you comments on that? No. Please, over there.
Good afternoon. My name is Karen Sudmeyer. I'm with the University of Lausanne. I'm also part of Geosciences, the International Union for Conservation of Nature's expert committee group on disaster risk reduction. My question is for the Japanese expert on green belts versus seawalls. We're large proponents of natural infrastructure for disaster risk reduction. And some of the reports I saw from Japan were that some people, instead of running away from the sea, they ran up to seawalls to see the tsunami approaching. So there was a bit of false security, I believe, with some of the seawalls. Now, what is your opinion about green belts, which may not be has as much of a barrier to cutting down the kinetic energy of tsunami, but keeps people away from coasts and has other benefits as well? Could you please comment on whether you think future development in Japan will include more green belts or more seawalls? Thank you.
Okay, but I also repeat the previous explanation. We need a very careful investigation. For example, in case of the one town, they have a very big seawall. Nevertheless, during the tsunami exercise, they carry out the tsunami exercise like every once a year or something. In that scenario, they assume that tsunami will overflow the seawall. So in that case, that village does not generate any casualties. So not only the so-called infrastructure such as seawall, we need a very so-called software protection. So maybe the Japan government needs a very careful analysis on this issue.
Are there answering?
If I may add a personal experience, following the 2009 Samoa tsunami, I participated in the field survey in Tonga and in the northern Tonga island of Niautaputapu. And the flow depth was 15 meters and the forest was eradicated. So the green wall, tree wall, maybe it works for little waves. When you reach the kind of amplitudes of flow depths that I mentioned, 15 meters, there is just no tree which is going to withstand that kind of onslaught. And then even worse, the trees become projectiles. And so I think we need to keep this in mind. And I suppose this also stands for the problem of the height of the seawall, which I believe was built to about 6 meters, which is a kind of a standard along the coast of Japan. There is a certain tendency always to build your defensive protection against in the framework of the last war. many wars have been lost because of that.
Just one quick comment. You might have heard Stuart Lane, who is of the opinion that defenses decrease the risk and the frequency, but increase the risk and the severity, because there's a false perception of security, and if something very extreme happens, then you have built right behind the defense. I think what works against that is serious gaming, and I think an earthquake like we just had is more than serious gaming, but I think these guys will know now. But I think for other areas, you know, risk perception and what we do with defenses is a very big issue.
Professor Kato?
Quick comment to your question is that the simple answer is just go away of the coast after the earthquake. Actually, that is what was told to the local people. When you feel a big earthquake, please go away to the higher place. That's only the answer. The March 11 earthquake showed us that none of seawall, no, not none of them, not none of them, but many of seawall didn't work. And probably even Greenbelt, as he said, might not work if the tsunami is much, much higher than that. So what you should do is to train yourself that when an earthquake is felt along the coast, you should go away from the coast. Then what should be done for the local government or government is to prepare the route to escape from the coast. That is very necessary. Actually, I heard many stories after the March 11 earthquake that the school teacher urged the pupils to go away to the higher place, and they survived. There are so many cases on that. So what is most important at the time of big earthquake along the coast is to just go away.
Yeah. Yeah, and then we should also...
And in case of this earthquake, Japanese Tsunami Warning Center issued the tsunami warning within 3 minutes. And last night, they issued it within 2 minutes. And, but nevertheless, Japanese Tsunami Warning Center instructs the public, don't wait for tsunami warning. If you feel a strong earthquake, please evacuate immediately. And also the NHK TV or radio, they also say make the same comment, because they start the breaking news after the second, and they immediately say, if you feel a strong earthquake, please don't wait, immediately evacuate. That is the combination of the so-called the public awareness and education is also the very important part.
Just a quick comment to Professor Okal. Sure, forests may not protect more than a seawall, but the seawalls didn't work very well either. People have a false security of they might settle right behind a seawall, whereas a green belt will keep people away. And I think seawalls are ugly and forests are not. Thank you.
It all depends on the height of a seawall. But I fully agree with Dr. Yamamoto that in the near field, the shaking is the warning.
Thank you. Other questions? Yeah, please.
Yeah, just a question on the seawall, since we're on this subject. Sorry, I'm behind you. How high would you build the seawalls now if you were trying to protect against tsunamis, since that's what many people are asking?
Well, I suppose it depends what you want to protect. And if you want to protect a house, if you want to protect a fishing community, you may look at the history, and you may look at 100 years of history, and in 100 years of history, now you have a 2011 with waves which have reached a run-up at some point of 38 meters, but which have typically been, reached 15 meters, 17 meters in places. If you go back, not very far back in history, 1933, there were waves of 15 to 20 meters on some of the Sendai coast. And of this particular region, following an earthquake which was smaller, but more intense in a sense because it was an outer-rise earthquake and so on. If you go back to the Great Showa earthquake of 1896, where 27,000 people were killed, which was a particularly slow earthquake, there were waves of 15, 20 meters. So looking at 100 years of history, we have 3 cases now. We had 2 cases, we now have 3 of documented waves of 15 to 20 meters. So how high do I want to build my wall? As I said, it depends what I want to protect. It depends what I foresee. Obviously, if I want to protect perhaps a critical facility such as a nuclear plant, I might build the wall a little higher. But it costs money.
Questions? Do you like to have to comment? Okay, sorry.
Hello, my name is Pavel Tkalic. I'm from Singapore. And my question would be either to Professor Kato or Yamamoto. Do you think that tsunami and earthquake warning system in Japan was working as intended, or it is not? And what is the message was brought from this accident to the future?
It's a very good question, but at this moment, I do not have any good answer to your question. As you said, Japan has established a so good tsunami warning system. And actually, it worked at the time of earthquake, and the JMA issued the tsunami warning within 3 minutes, I believe. And people began to evacuate, I believe. But somehow, the tsunami, the generated tsunami is much, much higher than we expected. So the tsunami warning was not very effective, I suppose. But one thing I could say is that we could improve the system for the future tsunami. The one thing may be that to deploy offshore tsunami sensors. So far, I think that tsunami warnings is issued based only on the earthquake information. Is that right? Maybe, yeah, no. But those use some offshore. Okay. Maybe he said that GMA use the offshore sensors. But anyway, we should improve that kind of system. And not just for predicting the tsunami based on the small amount of information, but also we should apply some good tsunami simulation, numerical simulation to applying to the real observed tsunami, and give warning, much more precise heights and reaching time to the local people, so that people have better information before the tsunami arrives. I think that's what we should do in the coming days. That could be one answer, maybe.
Okay. And as far as I saw the sea level data, the maximum big tsunami is coming after the 20 minutes or 25 minutes of the earthquake. So, but so in case of the coastal area in Sendai, in the Tohoku area, it's a very, very so-called steep areas. Very so-called the population density is extremely high because many people are living in the same place, in a very narrow place. And it means that probably it takes time to evacuate to the safety places. Also, it needs a lot of survey probably. And because in case of Japan, they have to develop the new evacuation procedures because so many people are killed by tsunami, even though the tsunami warning issued 3 minutes. So they have to devise the procedure. And, but I don't know at the moment the conclusion. But early tsunami warning, I can say it's a very effective way in order to mitigate the casualties.
Other questions?
Thank you. My name is Jan Lauterjung from Geoforschungszentrum in Potsdam. Following this discussion, also a question to Masahiro-san. Maybe we have to rethink in the whole UNESCO process a redefinition of the warning scheme. Now we have different warning levels, like 1 meter, 3 meters, above 3 meters, things like that. Maybe we have to rethink also this scheme with respect to all the evacuation planning and preparation of evacuation plans. I think that could be, for the rescue operations, could be a step to be gone in UNESCO, just as a comment. Thank you.
In current system in Japan, they have 3 categories. The major tsunami, it means they are more than 3 meters. And tsunami, just a tsunami warning. The major tsunami warning, more than 3 meters. Sometimes during this period, they issue the more than 10 meter tsunami also. But the actual tsunami, maybe some places more than the expected one. And major tsunami warning, the second one is just a tsunami warning. This means more than 1 meter, less than 3 meters. And in case of the less than 1 meter, they just issue the tsunami advisory. Tsunami advisory means no evacuation is required, but the beach should be cleared. That is the 3 categories. So Jeremy would think about how to modify if necessary.
Thank you. Comments?
Yeah, just I also thought rethinking this scheme in a sense of preparation to things like that, not only for the warning itself, but more important for the preparation to such cases. So we are now, or we can now have better models than years ago, and can, on a statistical basis, looking at the earthquakes, do much better preparation. And I think we have to really discuss this.
Questions? May I ask a question myself? So, okay, I follow the rule. My name is Stefano Tinti. I'm coming from University of Bologna, Italy. So my question is again on tsunami early warning system, and follow quite closely all the bulletins that have been sent out by JMA. There is the history, everybody can go on the web and see. And it was quite quick in the sense that 3 minutes later there was the first bulletin. But as far as I understand, it was the magnitude was 7.9, so we're largely underestimated. And as far as I understand, even after 1 hour, they went to magnitude 8.4, and probably they don't have any magnitude larger than 8.4 in their simulation for the tsunami propagation model. And then also I saw that there are in the bulletin this level that you say 3 meter, 10 meter corresponding to the different bulletin types are issued on the prefecture level. And so probably these are too roughly adapted to the geographical different needs of the different areas. And my question is, following one of the questions from the audience, what can be changed in the tsunami early warning system in Japan that can be useful for everybody? Because so far, unfortunately or fortunately, that system was seen, at least from Europe, but probably from any other part of the world, as the best system in the world in operation. And so we were much surprised that that system, in a sense, had failed to save a lot of people life. Probably it was successful in saving many more, but it didn't save so many people. And it was surprising to see in the video that there were many people with the tsunami wave inundating already, that were on their own cars, in the buses, instead they were there as anything was, probably they weren't unaware of it, or they were just unaware that that wave could have been so large. So something was certainly wrong.
Well, again, I may have to repeat the comment I did, that at least what we should do for tsunami warning, we really need offshore observation, but not just for observation, but also the prediction is necessary based on the real observation. So the combination of real-time monitoring of offshore observation and numerical simulation, which requires very high-speed computer, and get the prediction of the inundated, the height of tsunami at the arrival of the coast and the precise time of arrival, and give that information to the local people in a real-time sense. So far, as far as I heard from our tsunami seismologist in Japan, the numerical simulation is slower than tsunami itself. So it never succeeds, but still, I believe the computer technology will win to the tsunami, so that we will have, in the future, we could do real the data simulation to predict tsunami as precise as possible. Then I think it would be, the early warning system would be much better in the future.
Thank you. Yeah, sure.
And the current system is, in case of this time, the JMA issues the tsunami warning within 3 minutes, while the 3 prefectures, JMA issues the so-called major tsunami warning. After 20 minutes, or before 30 minutes, after the de-evaluation of the observed tsunami height, they expanded the major tsunami warning area up to, probably, I don't remember, the 6th prefecture or so. So based on the so-called updated, or based on the observed tsunami height and updated magnitude, the tsunami warning center is expanding or reducing the tsunami warning system. As far as we could not get a reliable magnitude within a short time, only a way, only this procedure is the only effective way. And also from an operation group of the tsunami warning system, I would like to ask the scientific community, please develop very reliable procedure to estimate magnitude within a minute or so.
Thank you. Thank you. Then, yeah, please. Short, please.
I would like to make one slight reservation here, which is that we need to remember that a large earthquake takes time to prepare. It's like good food. And therefore, there is an inherent impossibility to get the size of the earthquake because before it's over. So we need to keep this in mind, and there are cases of earthquakes starting small and growing later. So there may be, as good as these plans may seem, we should not try to outsmart Mother Nature.
Okay, if I can comment very shortly on the last question on tsunami, then we have to move on. Shortly, my comment is that very likely in each nation, in Japan too, but in many other nations, scientists maybe don't know, have a lot of limitation in this earthquake, show us that this was not expected. So the knowledge was partial, but probably there is also a need to have, to fill the gap that is present between the academic world and the operational world. Probably the last progress that has been made in Japan in many aspects has not been incorporated truly and perfectly in the routinely operation of the tsunami early warning. And probably this is also the case in many other countries for the Pacific tsunami warning system, etc., etc. So the last advancement should be transferred to the operation of the tsunami warning. That's my idea. So the last question, yeah, John McCloskey first.
I just would like, again, I'm John McCloskey from the University of Ulster. I would like to give my view and comment on your question, and I think what it implies for preparation. The problem with this tsunami was that it was the preparation was for the wrong earthquake. So, and I do not believe that we're going to be able to get, as Emil says, it takes a long time to work out what size a big earthquake is. So you can't do that in real time. You must have a reasonable expectation for the distribution of size that is likely in a particular area. In this case, for many reasons, it appears that was seriously underestimated. If we get that understanding to the right level, we can pre-compute thousands of scenarios, which will give us a traffic light system of red, very dangerous, orange, you still should try and move, and green, which has got different heights for different parts along the coast. Several people in this room are working on this type of approach for the tsunami warning system or evacuation plans for the city of Padang in Sumatra. We must revisit all of this in the light of the Japanese experience, but I think these pre-computations of probabilistic tsunami hazard based on well-informed earthquake scenarios are really the way forward for this.
Just, I mean, is that correlated to your question, possibly?
Yeah.
Okay.
It's very short. It concerns
can you identify yourself?
Again, Massimo Cocco, INGV. I believe also that we should abandon the classical seismological magnitude for the early warning. There are now magnitudes which are particularly magnitude estimates which are particularly tailored for tsunami, like duration magnitude, that can be computed after 2 minutes, even in this case. We have at INGV, we have online real time for the Japan earthquake, we computed 8.8 after 3 minutes. But so if you use to wait the moment magnitude, you will never have enough time. So why we do not abandon the classical moment magnitude and use the duration magnitude? Is a test approach, but it could be a likely answer.
I think I need to ask you if this new magnitude has been validated in particularly difficult cases. And I'm thinking of the delayed earthquakes such as Peru 2001 or Curies 2005. And I don't want to get too technical, but I want for the audience to realize here that in the business of issuing a red signal or a green signal, you have to have a system which is totally robust. Yeah. And I fully agree that there may be difficulties in obtaining a moment magnitude, but I think that the robustness of other measurements has to be established and validated, sure, including in very difficult cases, such as the tsunami earthquakes and the delayed earthquakes. In response, if I may, to John's comment of the green, orange, red light system, I would not like, and this is the reason why he is paid perhaps so much, but I would not like to be in the seat of a governor who is going to switch to orange only to discover that the earthquake was a red one.
Just a quick comment.
Very short, very short.
I'm not selling my stuff, so we are trying to validate and to corroborate. But this is not an initiative only done by us. There are several groups that are doing this.
Okay, let's close this topic here and let's move together, because the time is quite short now, on the impact and the economic impact and the incident, the nuclear incident in Fukushima. Now I allow question only on these two themes, if there are, of course. Okay, sorry. I've been told there is also the possibility to have an extension of the panel if you are interested to remain here. Okay, so we have half an hour more? Okay, at least half an hour more. So, okay. We move to the other theme, and then if there is time, we can also come back to the earthquake, tsunami, etc. Thank you very much for letting us know. Yeah, okay.
For the nuclear event?
Yeah. Exactly,
Can I ask a question? Okay. My name is Manuel Marquez. I'm from Barcelona, Spain. I'm in the Institute of Earth Sciences, Joan Mera. My question is basically obviously for this kind of subject that do you think that this nuclear event in Fukushima marks the demise or the decline of nuclear energy in the near future? I'm commenting because there are several social movements trying to combat the nuclear energy in the world, and now several governments are taking steps to close down or just cancel their nuclear plans in the future. Thank you.
I think this is a highly political question, and it cannot be answered purely on scientific grounds. I think everyone has his own opinion on this. Certainly it shows that risks related to nuclear power can be unpredictable. And there's of course other risks associated with the nuclear power. I mean, there is the unresolved problem of where to store all the nuclear waste. And there is other problems related to probably distribution of nuclear material. But I think this is a question that cannot be answered here, really. It's more on the political side. I think I would prefer to stay with answering questions that can be answered by scientists, really, on the concrete case and dispersion. Maybe you have more.
I think it has to be fully agreed. I mean, the accident in the Fukushima power plant is, of course, in principle caused by natural disaster, no? Not by this natural disaster caused the safety systems basically to fail then later on, and therefore, of course, I think the risk analysis people have to look at that, no? And in the construction of technological, how to say, assets and for sure also on nuclear power plants. I mean, this has to be taken into consideration. These aspects of natural disasters and other aspects of not foreseeable or of aspects that are not foreseeable when this power plant was constructed. So I think this is in that sense it's a scientific question then, of course, yeah, but it's probably the wrong panel here to discuss the security aspects on the design of power plants. Yeah.
But I find it interesting that if you listen to the talks and the answers before, it's not a question of likelihood. It's a question of we build, if much as possible, the highest possible dam in order to protect life. You don't put a likelihood on life. In our market, it's completely different. We take a certain risk, and we take also the potential of failure, of complete failure, actually. And our regulation accepts that, because there is in a tail in the distribution somewhere a possibility to completely fail. That is a very difficult question when it comes to life. And this is a discussion, we can't answer it, and you heard it before, it becomes a political question. If you look into nuclear power stations, as far as I understand, life is given a certain monetary value. Because they have in some ways to, because they have to give this answer to risk. We have in our market definitively to do that. We have to give a life a monetary value. And I completely understand that in the public, this is a very difficult field to discuss. But there are always risks we have somewhere to take. And of course, then there's the threshold. Well, that's a political question then. How much do you want, a regulator question or whatever? How much can we take and how much not?
I should probably would like to add that if you just look at accidents in nuclear power plants, they have all been very different. So answering this question cannot be done based on the Fukushima accident, because the next accident or the next incident in any way will be very different from this one. So I think we should stay with the discussion really on the Fukushima accident.
Comment? No. Okay. Thank you. Please. It was first. Okay. Sorry. First here and then here.
My name is Deepak Utfani from Deltares in the Netherlands. I believe in 1998 we had almost an accident in France with also a nuclear power plant with regard to flooding. And the similarity between these two is if I'm understood correctly, is the failure of having a proper cooling generator working at the time. This also happened in France, but also now in Fukushima. So I don't know whether we are saying that this is a natural hazard or something which actually should have worked but did not work. Do you understand my question?
Yes, but we are more experts on the dispersion of the material rather than the technical design of the plants. I mean, I agree that this is probably something that could be foreseeable. Whenever you have a loss of power and some failure to cool these nuclear reactors, then there is an immediate threat. So any reason, be it natural or man-made, of losing power to the reactor is certainly a large threat. But I think we should focus the discussion more on questions that we can actually answer.
Well, let's just go back to the tsunami aspect of this question, because the tsunami is what failed the alternative power, which created the disaster at the nuclear plant. And the question will have to be asked at some point, in my opinion at least. I'm not a nuclear engineer, but I'm a tsunami scientist, and the question will be asked, how come this generator, which was supposed to protect the nuclear plant against Mother Nature, how come was it built below the level of the tsunami of 1933? And I'm not referring to the tsunami of 869. I'm referring to a tsunami of 1933, 75 years ago.
Okay, thank you. Here?
Yeah, hello. Michael Whitworth, University of Plymouth. My question mainly is to Dr. Michel. How do you think that it sort of goes back to the previous question, but how do you think the change in the way that we evaluate risk, not just to earthquakes, but natural hazards, is likely to change from this sort of event?
It has changed. And what has changed already, and we see it in the questions we get, is that although insurance and reinsurance looks into the next year, or next quarter even if you want, because our shareholders do that, our models ran on long term. The idea for that was that the market is more and more a globalized market, and that you can diversify risk away. And insurers that are more local give then their risk into the global reinsurance market. And therefore it probably makes sense to look very long term, because you have different areas, and that is then diversified, and you can work with that. We more and more seem to understand that this is bollocks, that's not working. And we've seen it in the financial world, we've seen their correlation we didn't expect. And we see a lot now also in these natural events, that they come out larger than expected, that this diversification doesn't work for the tail. That essentially a tail can get you no matter how well you are diversified. And so people are now asking more and more for the short term. They ask for forecasting. They ask for effects we might have not included. Or keep in mind that our market still works in relatively small margins, which essentially means you can't go for huge security, because then nobody can afford it. The premium will be too high, nobody will use any insurance. We've seen in California, where essentially insurance penetration is going down, people can't afford it anymore, don't want to afford it. So we have to be competitive in our market. We can't overestimate the risk as well. That's a big cost, which is finally a bad thing. But what's happening is that people more and more now look into negative correlation. They try to get advantages of, for instance, are hurricanes in the US negatively correlated with tropical storms in Japan? You know, can we get some benefit on that in order to finally finance the much larger risks that might come in certain areas? Yes, there's a change.
Thank you. Comment? No. Other questions? Here. No, it was... No, okay. No, it was behind you.
It was some time ago. I'm Miguel Miranda from the University of Lisbon. I have two points. The first one was the following. Is it possible to make an economic evaluation of what was gained from the tsunami walls and the tsunami warning system? Because I heard too many negative comments, and I am not sure if they are proportionate. That means what was gained? Because for sure, lots of things were gained due to those systems. And the second point is the following. We saw lots of problems, for example, on the nuclear power plant. And my only concern is the following. Are they a consequence of bad behavior from the guys that operate this specific plant, or they are also a consequence of some under-evaluation of the natural risks? Because this is a business of us.
Who likes to...
No, yes, no, frankly, I can explain better. For my own understanding, we know that lots of times we have very big events in places where our hazard mapping is not so red. And my point is the following. Should we have evaluations based on statistics, or should we move to evaluations much more made on physics?
I might start with that. And that very much comes to what Nassim Taleb, most of you have heard of him, that's the Black Swan author, although the author of Fooled by Randomness is saying now since years, and especially after the financial crisis. So we are fooled by modeling. We are fooled in some ways here, and I put it in my own words, a bit also by modeling in Japan. We are fooled by the fact that we thought we understand the maximum earthquake. We have built our security on that. And then there was something larger. We are fooled by modeling here. We're fooled by modeling in many areas of the world. Does that mean we shouldn't model? Does that mean we shouldn't build? No. I think what it really means, and that's also what Nassim Taleb, for instance, says for trading, he says, you can only to a certain degree, in the higher frequency, lower severity range, understand the models and understand physics and everything else. There are certain events in the tail where the only thing what you can do to protect yourself against that is understand your limits, is minimize your limits and your exposure to those. There's no other way to do. This works for the financial world. It unfortunately doesn't really work for the real world, unless you would say the only consequence of that would be go away from the coast. Well, then there might be something inland, but we know that definitively in the US, for instance, more than 30% are now living along the coast, and that exposure itself is something you can't get away.
Thank you. There was a question here.
Jon Nisbet from Royal Holloway. I spent a while in China last autumn, including during the terrible air pollution event in November. And some of the very big air pollution events in China, the mortality may be as high as 500,000 people from coal-fired power. And I'm very moved by the problems that China faces. They have to make a decision between coal-fired power, which has, well, at the very least 222 radon in huge quantities, and terrible air pollution problems, between nuclear power with many of the populated areas having very high earthquake risks, a limited amount of solar power, a limited amount of wind power, and what they can do with the, well, obviously big rivers. And also, Japan was quite lucky that the Fukushima was on the coast and the wind was blowing out. Any recommendations, particularly from the air people, what should China do? Where do they go? They need power. My temptation is to switch off the light, but they can't do that.
I mean, it's true that the question of energy is important. I mean, what I've noticed I was last year in Kenya at a national park, and I've seen a power plant on geothermal energy in Kenya that was operated by Japanese actually, and I mean was by Japanese power and by Japanese staff being there, yeah? Which tells me that it's possible. I mean, especially in a region where there's a lot of geothermal energy, also to have this. Regarding the wind is actually a very good thing. I mean, if you look at the consequences of the accident, yeah, the position of the power plant close to the Pacific was, of course, one of the most lucky things. I mean, in reality, because there were several days in this accident scenario where the first populated area reached by the plume was actually California. No, I mean and that by this many thousands of kilometers, it's so diluted, yeah, that it has no harm on population. Yeah? So this is of course one of the lucky aspects of this accident.
I might want to add that one should actually not judge the risk of nuclear power by this accident, because as Gerhard has just said, they were extremely lucky that the wind was blowing sort of in the right way. So imagine the same situation in a nuclear power plant somewhere in Central Europe where, I mean, regardless of in which direction the wind will blow, it's just a question of which city you pollute most, and so the risk there would be much higher, although there will be no tsunami in Central Europe, at least not in the inland. But that could have been a much more severe event, even with the same source term. And also, I think it is too early to actually assess the risk and even the damage done by the power plant. I think this will take a long time to actually know how much radioactivity was released to the various environmental compartments. There was something going into the atmosphere. There was certainly a lot going into the ocean, and there's probably still a lot going into the ocean. And I think we do not really fully understand yet how much, especially regarding the ocean part. I think we do not understand the implications yet. How much of that will accumulate in the food chain and will probably also be returned to humans by eating fish, for instance, from this region. I think it's much too early to really assess the risk and then compare the risk to other risks and other alternatives, energy alternatives.
Comments?
Yeah, I actually worked on the Buncefield oil blast, which was Europe's biggest oil fire since the Second World War. And we were terribly lucky that was hot enough and strong enough to loft over the inversion. If not, we'd have had to have evacuated London. It was that bad. My response actually is conservation of energy. I can't think of anything better at the moment. Frightens me.
Thank you. Questions there?
Okay. Yes, I have two questions. We noticed that, again, Karen Sedmeier from the University of Lausanne, there were certain warnings that were put out in terms of the, I should say, the level of warning was put at a level of 4 by the Japanese authorities, whereas the Europeans and American experts are saying, no, it's actually a 5 or 6. So for the first week, there was debate going on, is it 4 or 5 or 6? But the European and US scientists seem to discredit the Japanese authorities on this. So two questions are, if this were to happen in Europe, can we trust our authorities? Did the authorities in Japan do this on purpose, take down the levels so as not to create panic? So would the same response in Europe be the same? That we take down the level a little bit just not to get people too scared? And if we did have this kind of accident here, are we prepared? Do we have iodine tablets for everybody and so forth? Thank you.
Who is? Yeah.
Yes, I mean, the accident, I mean, of course, it's, as my colleague already said before, is the exact amount of radiation emitted and so on, and then this basically drives the assessment of the accident is more or less still not fully established. I mean, yesterday there was a press conference actually from UNSCEAR, from the United Nations Scientific Committee for the effects of atomic radiation, that is in the building just next to here, at the United Nations building here in Vienna. And they say it, and I think that is something I would subscribe to also, that this has been something in between 3 Mile Island and Chernobyl, no? I mean, and somewhere in between, and consequently, I mean, the accident scale from the IAEA is between like 4 and the maximum. So that's the assessment. I think that's not much more to say to that. I mean, the data that have been available in the accident, that were more or less, how to say, available for everybody is, of course, outside the 20-kilometer zone of the reactor. Data have been made available, but not within, with the argument that there are no people living in this 20-kilometer zone, and therefore the data are not important for the general public. And I think this data is required actually for scientific evaluation, to really assess the accident scenario. I mean, we tried to do it based on data from the CTPTO measurement system, and I mean, the source terms we got certain substances. I mean, there are volatile substances in the reactor. There are gases, for example, like the radioxenon gases. And this release was huge actually, from Fukushima. There have been also releases of volatile iodine and cesium that was also very significantly released. There were other substances in the reactor that were making up the dose rates, for example, in Chernobyl, finally, that we think or others think have not been released in that much because there was not this explosion in the reactor. So what we need is actually for a thorough scientific evaluation, of course, all this data to look at. And I mean, what is also important for us is, of course, I mean, our assessments are based on models. And our models, they are very good regarding the weather. I mean, we have very good weather forecasts, and weather analysis on the satellite data. But the models rely still on parameterizations, physical parameterizations, for example, of rain out and wash out, that are maybe 10, 15 years old already, and there have not been so many experiments to validate. So for the modeling community, for us, it would be also important to, how to say, I mean, first of all, to use the data from this accident and to get more data and information, but also to get some controlled, maybe experiments and exercises where one knows the release rates, where the properties of the particles are established. And this, how to say, I think one of the lessons learned is that and this was the same last year with the volcano in Iceland, that this is important, the modeling, and should be kept on track. Maybe.
Okay.
Yes.
No. Wait for the microphone, please. Just a comment, not ask question more.
No, that wasn't my question. My question was are we ready for something like this here? And second, can we trust our authorities that they won't be underestimating the risk like they did in Japan?
We are ready. You mean what continent or what in Europe? You mean?
No, I live in France. I can give example of France, and I'm concerned. Is the French authorities, okay? You're Austrian. That's not fair, but are the French authorities ready to deal with something similar? And can I trust my authorities that they will give the proper information?
May I tell that it's an appropriate question here. Nobody here can answer. Maybe everybody here can share your doubts, but there are no authorities here to tell you that if they are trustable or not. So there are 2 more questions, at least. Please, over there.
Hello, I'm James Annan from the Japan Agency for Marine Science and Technology. I live and work in Japan, and I wonder if you have any explanation for or understanding of this extraordinarily paranoid and hysterical reaction we've seen across the world to this event, which, as far as I understand it, has had relatively minor health impacts on humans and will have very minor compared to the alternatives that the alternative power sources, as we've heard, from the dangers of coal, for instance?
Well, maybe that is due to the fact that there was no international body, or maybe even looking into Europe, no European body that would have assessed the situation. What was available to people was mainly data provided by various sources, but very uncoordinated. So Gerhard did, for instance, forecasts on the dispersion of this radioactivity. We did simulations. We got many requests. People from Hong Kong mailed, "Are we under threat now?" But there was no international response to the whole situation. And I think that's why people really got confused in the end, because nobody knew how to interpret becquerels or sieverts really. Certainly there is no immediate health risk associated with the levels of radioactivity that are now coming into the US, or have come already into the US and into Europe. The main concern, or the only real concern, is actually what happens in Japan, and that's where it doesn't make sense that people, of course, in Europe or North America are buying iodine tablets. They should leave those to the Japanese, who really might need it. But the confusion was partly, I think, caused that there was no coordination whatsoever in terms of the response in Europe and North America to that accident.
Emil?
If I may ask a follow-up question, is part of this hysterical response perhaps due to the fact that we don't know in the public at large where we are going? Can we do we have a handle on those reactors, and we can reasonably well predict what's going to happen in the coming weeks or so? Or are there still questions about this which could explain a concern on the part of the public at large?
Well, I mean, I think you know at least the sort of radioactivity, the amounts that are in the reactor. And I mean, even if you just release everything more or less that can be released into the atmosphere, I think there would be no immediate threat to North America or Europe. So I think that answer could have been given quite easily. Of course, there's a huge threat to Japan. I mean, there's no question, and maybe also some other Asian countries close by. So the focus should, of course, from the very beginning have been onto Japan and the immediate surroundings, and the question is not whether Europe or North America will be contaminated. We should rather pose the question whether our nuclear reactors are safe. Of course, that's a different question. I think there was the international bodies who are probably supposed to give these answers, like IAEA, they probably have been sleeping. I mean, somebody should have stepped forward and should have given that answer to the Americans and to the Europeans early in the event. Instead, it was a rather chaotic grassroots movement by people providing answers, and of course sometimes also conflicting answers.
Thank you. There was a question. Yeah?
Yeah, my name is Petra Seibert from Vienna. I've been involved in assessing Chernobyl consequences in Austria, and since then been involved in many hazard assessments for nuclear power plants in Europe. I'm a meteorologist, and maybe I can offer a few comments on the topics raised here, if it's permitted. So I think we have to understand that from the side of the experts, it has always been clear that there can be major off-site consequences of severe nuclear accidents. Whereas on the other side, before Chernobyl happened, this has not been put at all into practical emergency preparations beyond a very small emergency preparation zone of a few kilometers typically around each site. After Chernobyl, that has obviously, it had to change because it was so obvious and something has happened. And I was kind of surprised to see the situation as a kind of déjà vu, because still, as Andy Stoll mentioned, things looked quite chaotic, and the information was partly withheld or partly just not really available, and the organization can certainly be improved. That is one thing. But on the other hand, I think there are in every country, or almost every country, especially those having nuclear power plants, there are radiation protection authorities, and they have invested a lot in all kinds of infrastructure in the past decade since Chernobyl, and in a way they are certainly better prepared. But I personally doubt that we are well enough prepared in reality. There are many, many technical features that we can point to, like still emergency preparedness zones where people are exercised on evacuation and so on. They are never like 20 kilometers in diameter. And as we see, 20 kilometers maybe still is not enough. Or for example, iodine tablets should be stocked in a relatively large area around a nuclear power plant. And in Austria, like they are stocked in all the schools and kindergartens, but that is only because like Austria is quite on the watch in terms of nuclear emergencies. And that is also related to another important aspect, namely that everything is connected very much to the interests of the nuclear industry. And nuclear industry is, of course, very much afraid of public perception of the risks associated with severe accidents. And it is in many countries, like Japan and France, for example, is closely associated also to the government. And so there is many like interaction that is shaping the way how different countries both prepare and react to nuclear emergencies.
I would like to add that I perfectly agree with what you have said, and I was also really surprised that despite the fact that there have been national and European exercises repeatedly every year and even more often than yearly on these scenarios, mainly of course of a European accident of a nuclear power plant, there was a complete lack of coordination. And I'm sitting here the second time in a year. Last year it was the Eyjafjallajökull eruption that caused complete chaos and sort of a lack of coordination, and now it's this event. And I'm really wondering whether Europe doesn't need a sort of emergency response center for Europe. I'm only speaking for Europe, of course, but whether there is not a center needed that can give competent answers quickly. Like we have weather forecast centers that are pretty operational. Why not have a European center that is prepared for geohazards and hazards related also to nuclear power? Since it's quite obvious that the response that we have seen is insufficient. It has to be improved, definitely. I mean, if something would have happened in Europe, I also don't want to know what the response would have been when there would have been a real threat for Europe.
Okay, thank you, Andreas.
Yeah, maybe to add, sorry, regarding the international part, I mean, after the Chernobyl nuclear accident, there have been a lot of international preparations been conducted, and also, I mean, the International Atomic Energy Agency got support from, for example, from the World Meteorological Organization, and I mean, these support mechanisms, of course, to a certain extent running, yeah. But I would also agree that this, since this accident gives a chance to look at the procedures and to look at the effectivity of the system, I would also agree that this has to be really urgently looked at after, and lessons have to be learned on how this should in the function in the future, so that we can then be more, how to say, can more rely on these processes when other areas in the world and the other reactors and reactor areas, when they are how to say, not when the plume is not going to an ocean and hitting populated areas. So that's very important, I think.
Thank you. I take only two short questions to end. Please, over there, please.
Yes, Randy Shostak, reporter with EOS, the newspaper of the American Geophysical Union. Just to follow up a little bit on what you've just said, I'm wondering, in the aftermath of the nuclear incident in Japan, what is the responsible thing to do now regarding other nuclear plants worldwide? And what would panelists recommend in terms of scientific study, modeling, risk evaluation, plant protection, etc.?
Well, the first part of your question is partly, I would say, political, and it has to take into account other things than just Fukushima, as I said at the beginning. I think what we have to learn, or what we have learned from this event, is that there can be things that are unexpected, that are completely out of the question, or out of the equation, that have been put into assessing the risk of nuclear power. So it's certainly, I think one can say, it's more dangerous than many people have thought. Regarding the second part of your question, I think what can be learned is that, as Gerhard has said previously, we need better models also to predict what's happening. That concerns probably ocean models, but that also concerns especially atmospheric models, because that's the immediate threat to people. And I would also support the idea that we need to further develop these models and test these models. So my suggestion would be actually also, like Gerhard said, we need an experiment where we test these models by releasing artificial tracers into the atmosphere, and with a known amount and a known release scenario, and then we can model those, and then we can compare this to measurements taken. And also determine the source term, because that's all important now in this real-time situation. We want to know how much radioactivity has been released from Fukushima, and for that you need accurate transport models. But there is very little opportunity to test these models, because fortunately these accidents are not happening too often, and they have a very unknown source term. So in order to improve these models and test these models, and both this volcanic eruption last year and the Fukushima incident now have shown how important these models are, we need to evaluate them. We need an experiment to test these models and improve them. And then, of course, there's all the other implications on how to respond politically to these situations.
Thanks, Andrea. Emil?
Well, I think also from a standpoint of trying to go back to what produced the incidents in the first place, what is in order is a review at nuclear plants which are located on shorelines, and many of them are, is a review of could it happen, you know? And in particular, I would say, you know, using perhaps some very crude language, try to establish what is the exact height that we've put these generators on at, with alternative diesel generators, make sure that they are not at sea level, that they are a little bit higher. And so I know that is really symbolic. What I'm describing here is symbolic. There are also some stronger issues, but I go back to the fact that these generators were at the wrong height and were below the well-known tsunamis level of flooding of the well-known tsunamis of 1933 and 1896. And I know, for example, that France has embarked on a project to review the safety of nuclear plants. And I know that there had been in Japan about 2 or 3 years ago a committee which looked into this, and apparently at least one member of that committee did blow the whistle on the problems of large tsunamis along that coast, which was documented in particular in the paleoseismic record. So I think that what's in order is you learn by experience, and what's in order is to look at whether these various nuclear plants, how would they have fared under a similar condition. And then perhaps to listen to the conclusions of these committees.
A very brief addition to this, I'm also wondering at what altitude levels these generators are inland, because are they prepared for a major flood really? I mean, not a tsunami flood, but I mean just a regular flood, which happens very often. But are we all prepared for major floods that are probably happening on a timescale of not every 20 years, but every 100 or every 500 years? Do we really assess the risk to just normal flooding by intense precipitation events correctly?
I think you have Katrina in mind, don't you?
Yeah, for example, like something like this.
Yeah. Essentially, the pumps in New Orleans, which was supposed to keep the water out, which were below the sea level, more or less.
What killed the power plant was not the earthquake, it was the tsunami. Absolutely. It was water, and I mean, water cannot only come through a tsunami, water can also come by heavy flooding.
Okay, thank you. The last question.
Yeah. Yeah, Pavel Kalic from Singapore. Somehow it happens that I have been participating in consequences of Chernobyl accident and also building of Singapore Tsunami Warning Center. And I see much of similarity between Chernobyl and Japanese accident and between 2004 Indian Ocean tsunami and Japanese tsunami. The similarity is that that time, 2004, all scientists would say, okay, we have to build more models, better models, more GPS stations, more sensors. And somehow that was message across the world. And still, and now we hear all the same, more sensors, more models, better models. So the same Chernobyl accident, at that time, it was developed a Rhodos system, all European system. I don't know why you have not mentioned it here. It's fully functioning and working for entire Europe. And moreover, the give product about Japanese accident, I was receiving, because I was in developing thing, so I was receiving those bulletins with those two population for next 10 years in Japan, due to eating fish and other things. So somehow that information was not transferred to Japan. I don't know for what reason, but there is information, the system is working. So what is similarity is that somehow we tend to have a scientific, increase of scientific level of this accident, but it's not that scientific level. Somehow information must be proper channel and distributed. That is what my message is. Right, thanks.
Thank you. Who is? It's a statement. Yeah. I know. Please. I was taking a question, so this is the last question. That was a statement.
Yeah, this is a question. It's a question of concentration. It took us about 70 years to make big aeroplanes safe, or relatively acceptably safe. And even nowadays, the Brits wouldn't put the entire royal family on one plane. We had 6 reactors, was it, in Fukushima, altogether big reactors. Also, of course, there was a big oil fire, very big oil tanks all together, which could have produced a huge air pollution event if the wind had been going to Tokyo and it hadn't lifted. Should we concentrate all our facilities on one place, or should we spread them around? And I see the insurance expert has gone, but any comments? Should we spread it around? Then at least you only have one problem in one place.
Thank you.
I guess we should definitely not distribute them where people live close by. I mean, that's regardless of whether it's only one plant or 6 plants. I think people living close by, that's an immediate danger.
So now I think we should, unfortunately, we should close here. I thank all the panelists very much. Unfortunately, 2 other panelists had to go. One to catch a plane and the other because at 3 it started another session. So Professor Kato and Michel because he had to catch a plane. So he regrets, but he couldn't stay here until the end for this half an hour extension. So I thank the panelists first, but more the audience that had the patience to stay here to ask very interesting questions. There are conclusions probably to draw, even though I'm not so expert to draw conclusion on behalf of the panelists and of the audience. It was a pleasure to have, in a sense, the voice of the EGU this morning and this afternoon through this panel to be conveyed probably through the press to the public opinion and through the EGU presidency probably to some authorities, but the point of view of the EGU on this or the contribution of the EGU to this big catastrophe that had changed our scientific view on the interpretation of the physical phenomena had changed or had posed a lot of problems in how catastrophes have important, great relevance for the society. We've got a division here that is called natural hazard, that is the ones where we want to fill or build a bridge to the society. So this is the most important part of our work here. How what we achieve through science in our common work and in these assemblies where we compare our results and our point of view can be exploited, can be passed to the society in order to progress and have a better world. Thank you very much for your attention again.